Moving into the photoelectric sensing modes. So we've got three types of sensing modes, or the basic types of sensing modes. There's some other subsets that fall under these three main ones, but these are the top ones. And we'll go through and talk about each one individually. So transmitted beam, you can see by the diagram over here, we have an emitter and a receiver separately, independent from each other. The advantages, detects emitted light from the source unit. They provide the highest margin. So for dusty, dirty environments, it's the most reliable from that standpoint. It's also the most reliable over long distances. And then also they're not affected by surface reflections like stretch wrap and issues that we'll talk about on some other things a little bit. The downside to it or disadvantages, they require two wires going to them because you're wiring to the emitter and the receiver. So it's additional installation time and cost, and then also it's a little bit harder to align. Retroreflective is by far the most common type we see out there for general sensing applications. It detects basically the reflector or the light being reflected off the object, so it can tell the difference between the reflector and the amount of light being reflected off the object. These are the ones we typically see issues with, though, with like shrink wrap type products, stretch wrap around. So we'll talk about some ways to handle that. You can see it's got a much shorter sensing ranges than the transmitted beam. Nice thing is you're only wiring to the emitter and receiver because it's combined into one unit there, and then you have a reflector that's mounted on the other side. Another version of the retroreflective is the polarized retroreflective. Basically, the sensor itself has a polarization filter built into it to help reduce some of the false triggers that you get out of objects that are highly reflective, like the objects with shrink wrap or stretch wrap around them. So this is one way of dealing with that. But again, when you do that, add that polarization filter to the sensor head, it reduces the sensing range again even more. So just keep that in mind. A lot of times, if you have a retroreflective sensor application, you can use a polarized retroreflector sensor back in its place, but might not necessarily be able to go the other way. If you're in a down situation or need a sensor quickly, again, you may be able to use this as long as you don't exceed the distance limitations. The other kind of big broad spectrum sensor is what we consider the standard diffuse, and has some subsets under the diffuse type sensors. But this is a sensor where you would be using without a reflector or can't mount something on the other side of a conveyor potentially. They uses the amount of light reflected directly from the object to detect objects. Good sensing ranges are less than 10 feet. Most of the time, it's less than 5 feet. So again, if you get out to 10 feet, you're doing pretty well with a diffuse style sensor. Again, some of the disadvantage of this, it's commonly you'll pick up objects behind the background you're trying to pick up. So if you're looking for objects that are coming down a conveyor from the top, you may actually pick up the conveyor itself. It's a little bit harder to tell the difference between the two. They're also affected by the color of the objects that you're trying to sense and texture, more so than any of the other sensors. One of the other wide diffuse model sensors is a wide angle diffuse. This was a pretty popular sensor in the past. It's not as popular today with some of the newer, more advanced sensors and sensor technologies that's come out. But basically, they had it offered a lens within the sensors that offered a wider focal point. So if you were looking for a small object within a bigger area, you could use those. Sometimes they were dependent on the target color, shape, and texture. But potentially, if you had an object that had multiple little holes in it or things of that nature, you didn't want to see the holes or have the sensor beam penetrate through the holes. You could use this and look over a broader area. The other area where these sensors were typically used was like thread detection. If you had a single thread that could be bouncing back and forth around in an area and you were looking for that thread break, you could use something like this. The fixed focus diffuse was another one that was an older technology that's out there, been around for a long time. Basically, it had a set focal point, so very narrow window where you could look at with the sensors. They typically also had very short ranges. These were a lot of times used for color registration mark applications and things of that nature, or very precise locations where you're looking to detect an object. The fixed focus has been somewhat replaced by this next sensor, the background suppression style sensors. They've taken the place of a lot of the fixed focus applications. Reason for that is the background suppression style sensors, the cost of them has just come down tremendously over the years. Again, they offer a lot more flexibility because you can adjust those cutoff points where it does not see beyond. So if you have potentially, like I talked about, the object laying on a conveyor, coming down a conveyor, you can pick up an object that's coming down a conveyor and not sense the conveyor if you're looking down from the top. Some of the older versions of the background suppression sensors, you actually adjusted a screw that adjusted a mirror inside of the sensor, was how they did this. You can see the newer sensors actually have a self-teach function, and so it's all done electronically within the sensor itself. Just some examples to be aware of when you're looking at the sensor and sensor outputs. Depending on whether it's classified as a dark operate or a light operate sensor, the output can be on at different times. A lot of sensors can change or be changed by a switch on the sensor itself or be programmed by a push button teach. But the difference between a dark operate or a light operate sensor is basically when the output is on, whether it's while the object is present or whether the object is not present. And as you can see, depending on what type of sensor it is, it changes. These are all examples of dark operate setups. And then you can look at the light operate examples here.